flaky tests. Favorite topic? Everyone's favorite topic, right? Um, all right. From flaky to reliable, trusting your test automation. I'm Titus, developer advocate. I'm lead for Selenium. So let's talking about test results, talking about how they relate. Let's put some structure around this. So there's this test status matrix where for any test, for any feature that you're evaluating, that you have a test for that feature. That feature can either be working or not working, and the test for it can either be passing or failing. Most of your tests should be passing and most of the time the feature's working, your test should be passing. This is where you want things in general. Where we spend most of our time is the feature's correct, but there's some problem with our test that's causing it to fail. It's type 1 error, otherwise known as a false failure. And we spend most of our time trying to figure out the difference between a false failure and a real issue. So we've got a failing test. Most likely it's a false failure because that's just statistically where most of these are for most people for a bunch of reasons. But figuring out whether it's real or false failure is really important. And for completeness, and actually the scary one is the type 2 error. Not going to go into that a whole lot this session, but essentially it's kind of scary when you have a test that you think is going to catch a problem. That problem exists. The test that you have that should catch it does not. And so you end up releasing your code with a false sense of confidence based on an inaccurate assessment of the quality of your tests. We're going to focus on the bottom two here, especially the type 1 error, false failures. So I've made a list of 10 different reasons why your tests could fail, even though the system's working as intended. So this could be a matter of insufficient system resources, network issues, inconsistent start state. I'll talk about that more in a second. Dependency issues. So this is stuff like Selenium has a bug, or there's a Java issue, or something that's outside of the control of the test itself, but it's not. The test is failing. A version issue, a browser driver is wrong. Something that your test needs to execute that isn't related to whether the site itself that you're testing against is working. Faulty test logic, configuration issues, test data conflicts, synchronization issues. The website feature has changed. Uh, so that one's a weird one because the system is working as intended, and maybe like the features changed and went from a drop down to a radio button or vice versa or something like that, right? So the feature exists. You have a test that's supposed to evaluate did it work, but because the feature itself has changed, it's not just a redesign, it was changed the flow of some form. If the test hasn't been updated for that, it will fail even though the system was working correctly. Same thing with site design updates. All right. So these can generally be split into things that once they start failing, they're always going to fail, and things that sometimes they're passing, sometimes they're failing. These are the ones that I think are going to be flaky. Like if you've got a Selenium bug, most likely that bug is always going to affect your code. It's possible that there's flaky bugs and things like that, but the ones that we're going to focus on here are these infrastructure issues at the top and then the code issues there in the middle. So let's start with the infrastructure issues. So where are you testing? How's this working? I have had all of these problems in the past. Where you're testing from. So where is the code executing? This is your CI/CD tool. Oftentimes we'll have an underpowered Jenkins server that everyone's using that is we're going to try and run 100 tests in parallel with Java. That's not going to work because Java uses a lot of processing power. Running 100 processes, 100 threads at the same time is not feasible, especially if you're using a shared CI tool. So I've definitely had a problem where my tests were inconsistently throwing random weird errors because the code that we were executing was too powerful for the machine executing it, and it couldn't keep up, and it was throwing weird failures. So one thing to rule out when you are evaluating flaky code is what is my CI tool, am I putting too much burden on my CI tool? And then similarly, the system under test itself, where are you deploying that? This could also be an issue of like your large staging environment locally. It could also be underpowered. But I've explicitly had this issue. Uh, the DevOps deployed our site somewhere and they thought it was just for someone to like take a look at it. Like, we'll deploy it somewhere. He's like, I deployed it to the cheapest AWS instance they had just so we could take a look. And I'm like, no, we're trying to run 50 automated tests against it simultaneously. And he's like, oh, yeah, no, that's not going to work. And so I'm like, all right, so let's get a better instance to deploy it to so we can run our automated tests in parallel. And then this one here is just it's the network where things going from one place to another. It's your the commands are going from your CI tool to the virtual machine with the browser, and the browser has to load assets usually through a tunnel, and then through the tunnel it accesses some server in a DMZ, and that server is going to access some things from the private cloud, and it's going to access some things through a load balancer that then goes through different services in your private network, right? And anywhere along the line, a network issue, some bad routing, something can cause a failure there, and it's not always easy to ensure that everything is good. Um, Often you're going to be just trying to minimize how many hops and trying to make sure that things are closer together. And then the final one is where you're testing it on. This is like a Sauce Labs virtual machine is a great example of this solution. I have in the past had many issues where cookies from a previous test caused a problem. The order in which I ran my test caused a problem. State was set from one test that affected a different test. So part of this is part of this is how you're processing your test, but the other thing is if you're running each of your tests in isolation on Sauce Labs, you're getting a known start state every single time you start the session. It is giving you a brand new virtual machine with the exact same state that you're going to get every single time you start the session. And that's not something that you get when you run on your local machine necessarily, or if you're running a bunch of tests in the same session. All right, test data. And I've talked about this in other places, but here's a with fun new graphics from our friend ChatGPT. Test data can cause problems with flakiness, especially when you're running things in parallel. You want to make sure that there are no conflicts, that two different tests aren't trying to do different things with the same data. And so the big overview here is there's four different ways that you can do test data management. The first I like to call grab and hope. You just pick the first thing and hope that it's in the state it needs to be in to work for you and that nothing else is using it and everything else will be fine. This is usually the one that people start off with first. Static reference, this is how testers solved the problem, is that they just created these huge spreadsheets. So usually you've got a standalone test environment of some kind, your staging and testing environment, pre-populated data, and then you just create huge tables of all of the stuff. Yeah, we did this at one of my companies, and it worked pretty well until someone accidentally deleted the staging environment database, and then we had to repopulate everything that we had painstakingly been using over the last 6 months to test all of our things. That was a pain. It's just hard to maintain too, and you end up with just a lot of data that you don't really need to pay attention to. Fixtures, this is kind of how devs answer it. Instead of just maintaining a table of existing stuff, it's like, well, how about we'll dynamically create it, or we'll drop the database and then insert in our own stuff. And then we'll use that for testing. But you still have to keep track of which tests are using which data. And the data itself doesn't necessarily end up in the system the same way that a user would put the data in the system. So it's not necessarily testing reality. Recommendation, just-in-time data. We got the little image of our 3D printer there, printing something as you need it. Essentially, if each of your tests is responsible for all of its own data, there's no possibility for data collision. Everything is going to completely stand alone and work every single time, and no possibilities for flakiness as a result of test data. All right. Synchronization, this is the main one when we talk about flaky tests. Almost every time this is the issue. And then there's easy ways to address this and hard ways to address this. The I break up the synchronization strategies into four different pieces. Two of them are local solutions, two of them are global solutions. The local solution means that every time you need something to synchronize, you need to wait, you need your code to wait for the browser to be ready for the next execution. You can either put a hard-coded sleep, a time, of some kind to say, hey, code, just generically wait X number of seconds or milliseconds before taking the next action. And everyone knows you shouldn't do that. Everyone knows that that's dumb and that it causes other problems. The thing is you never know how long you need to sleep in order to make sure for sure that it's ready. And if you put your sleeps long enough, then it ends up just making the whole test take forever to run. Am I gonna categorically say it's never the right answer and you should never ever do it ever? No, there are probably places where it makes sense to, like, I don't know. Would you rather spend all day trying to figure out exactly what you need to wait on, or sleep for 10 seconds here and that's always going to be good enough and it's just 10 seconds of execution time rather than 10 hours of my life trying to figure something out? But it's a crutch and it causes problems, and a couple times is not a big deal. A million times is a big deal. So context matters. The other option for local is an explicit wait. This is where you figure out exactly what it is that you need to wait for that, and then continue. This is the best practice. This is what's recommended. This is what everyone talks about. Great idea. Yes. Always figure out exactly what you need to wait for. Always wait for exactly that. Put those everywhere. The problem is it's hard to keep up. You end up with these explicit methods everywhere, and they're often unneeded. When I was working with Water, which is a test framework based in Ruby, and back in the day, present. So you would define the element and then call dot when present dot click. And when I took over the project a number of years ago and I'm looking at it, I'm like, why are we doing, like, as a tester, when would I ever want to click an element that wasn't present? Like, that seems excessive, especially in Ruby. Like, why are we being too wordy here? Let's assume it's present. Let's force it to be present, kind of an idea. So, but the problem is we just everywhere had when present, and so you just put it in all of your code. It fails. So like, oh, well, maybe it just wasn't present. Let's add that first and then see, and then let's add something else. And it's just makes the debugging process a lot harder. So on the global side, I would much prefer a global solution to a local solution because you're making a change in one place and it applies everywhere and it provides a lot of value for the amount of energy you're putting into working with it. Implicit weights are a great idea. You set it in your in your configuration, in your capabilities. You set an implicit weight value of a certain amount, and it will wait. The idea behind an implicit wait is the driver, if it doesn't find an element, if you go to find an element, the driver will look for it. If it doesn't see it, it will immediately raise an exception back to the Selenium code saying element's not there. An implicit wait is saying, well, if you don't find it right away, wait at least this long before you throw that error. So if you find it, return it. But if you don't find it, keep looking for this amount of time. And so that's great, except for most of the time, when you need to wait, it's going to be more than a short period of time. And when you add an implicit wait of 10, 20 seconds, it starts to get weird when it interacts with explicit waits. So you end up in this weird situation where your implicit weight is too short to be effective, and if you make it long enough to be effective, it messes up your explicit weighting in a bunch of places, and you pretty much can't get away with just doing explicit weights or just doing implicit weights. You have to have explicit weights, and an implicit weight value that's going to solve most of your problems is going to cause problems elsewhere. But it's a one-line code change. I generally recommend if people have a lot of problems, try setting an implicit weight with a second or two and see if your test suites have a better pass rate after you set it. We did run the analysis in our user database a few years ago, and we did detect that people that tests that used an implicit weight were more likely to fail than ones that didn't. So there is data that supports that tests that use implicit weights are less mature or more likely to have problems. The issue with implicit weight isn't necessarily the idea so much as it is the execution. So the way that it works with explicit weights is bad. The way that it works with where in the process it's finding something and what happens as a result. Um, so an abstract weight is a better is my answer to how to have the benefits of an explicit weight with the in a global setting. So let's actually look at the specifics here. So hard coded sleep in Java, right? You're doing something and you're just saying sleep for 2 seconds here, 2000 milliseconds, and then hopefully after the two seconds, this email element will be there, and then we can continue. The implicit weight, you just set it as part of your options. Just set it a seconds, 2 seconds, and then now every single time it locates something, if it doesn't see it, it will wait up to 2 seconds before it complains. So the explicit wait is what we recommend people to do generally. This is where you'll see all of the recommendations online. And usually there's an expected conditions class and a specific condition you're passing in with the location. And this is we're defining it with this given timeout and saying explicitly wait until this locator is present. And then once it is, continue. And if it's not, throw a timeout error. So the idea that I have behind one of the issues with the abstract wait here is, or sorry, the explicit wait, this is happening when you're locating the element. So it's doing the wait on the well, this is so explicit wait is very powerful because you can pretty much do anything, but oftentimes you're waiting for the presence of, or the visibility of, or the enablement of the element. The implicit wait only happens when you're locating it, not when you're trying to use it. And so like there's kind of a delay between when you have it and when it has to be used, and that causes some of the problems here. So the way I kind of combine these two ideas is to have some kind of abstraction. This is not the way I would actually do it in a real framework, but for purposes of explanation here, you have some kind of abstraction for clicking the element, and you do some kind of weighting, and then you click it. And so these two are now kind of tied together. We're not just locating it and then maybe doing things and then clicking it. It's all part of the same thing. The obviously this has a number of problems in it's constantly relooking things. It's going to be this is going to look things up every single time before clicking it, so you're not storing things across commands depending on how often you're using it. But you know for sure that the element is going to be there before you click it, and you don't have to worry about weird implicit weight and explicit weight conflicts. The next step here, how about instead of instead of waiting for something beforehand, just click it. And if Selenium has a problem with the click, it'll let you know, hey, we actually couldn't find the element. Hey, we found the element, but it's not visible. Hey, we found the element. It appears to be visible, but it's not clickable. Whatever that is, just take the action. These things get located, get used together, and then you deal with whatever the result is and try again. So something along those lines improves performance, and you have all of the and allows you to cache things as well. It's essentially all of the power that you get from a global solution, all of the ease of a global solution with all of the power of an explicit weight. All right. So that's big picture, the things that are going to cause flakiness in your test suite and the big picture things that you're having to think about and do